Advanced Higher Chemists, this one is for you. A lot of people get very confused with atomic emission and absorption spectroscopy, but actually it's not that complicated. So essentially, atomic emission and absorption spectroscopy are two techniques that can tell you what elements are in a sample and how much of the element is in the sample. And they're basically both opposites of each other. So the absorption spectrum shows you the energy that has been absorbed by an atom when it has been bombarded with heat energy and the electrons have been excited, whereas the emission spectrum shows you the energy that is then emitted when those excited electrons fall back down to the lower energy levels. So when the atoms absorb energy, the electrons get excited. It is that energy that is absorbed that comes up in the absorption spectra. Then the electrons can't stay in higher energy states forever. They have to fall back down to lower energy levels again. So then the transitions that happen when the electrons fall back down then give you the lines that are on the emission spectra. So this is why we get multiple lines on the spectra for hydrogen, even though it only has one electron per atom, because in each individual hydrogen atom with that one electron, there are multiple different electron transitions that could happen that all require different quantums of energy or give out different quantums of energy, which corresponds to different wavelengths. And remember, when we did the electromagnetic spectrum, we learned that photons of light that have a lot of energy have low wavelengths, and photons of light that have low energy have long wavelengths. So they're basically opposites. So we look at the hydrogen emission spectrum here. It's these lines down here that have been produced by photons with higher energy because they correspond to the shorter wavelengths of light. So don't overcomplicate atomic emission and absorption spectroscopy. The answers are essentially in the name in terms of what is causing the lines on the spectra. So whether it's the initial absorption of energy that causes the lines on the spectra, or it's then the resulting energy that ends up being emitted. And because every different type of atom has different electronic configurations, it means we can use it to identify types of elements because it's like they've essentially got their own fingerprint. The other cool thing about it is that the intensity of the light emitted is proportional to the concentration, which means the higher intensity, the higher the concentration. So as well as using it to identify what you've got, you can also use it to identify how much you've got. If you're looking for a more in-depth tutorial on atomic emission and absorption spectroscopy, then head to my YouTube channel. You will find a full tutorial video on my Advanced Higher Chemistry playlist.